Welcome back everyone to another video, and this one we will be taking a look at something called Buildroot. Now Buildroot is a very specific tool used to make embedded Linux easy, and that means you can create your own custom Linux based operating system with simply selecting or unselecting a few options and customizing it according to your need. Now this tool can be used even by someone who is really new to this stuff, or someone who has a lot of knowledge. This tool is very powerful and simple at the same time. So today we will be seeing how to set up a very basic Linux based operating system for your Raspberry Pi with basic graphical user interface and basic set of tools to get you started. So first of all, of course, you would need a Raspberry Pi 3 and you should be running Ubuntu 16.04, which is currently suggested as the official supported operating system for Buildroot. Now if you are using something else, you can also go ahead and use some sort of virtualization method as you wish. So for now we are going to see how to download Buildroot, which is pretty easy, and that is to actually directly get the GitHub. Now they do suggest taking a look at their tar releases. Getting it from GitHub means ensures that you have the latest piece of software, so it can be sometimes buggy. So suit your needs, you can either get it from the compressed archives or directly from Git. However you choose to do it, you would end up with a directory called Buildroot, and the first step is to change to that directory. So cd and Buildroot, that would do the magic. Next up we have to, so this thing, if you're familiar with kernel's kconfig or configuration method, this thing follows the same. So first we have to kind of make the Raspberry Pi 3 def config. Now if you want the other Raspberry Pi def config, we have the Raspberry Pi 2 def config and the Raspberry Pi def config, which works with Raspberry Pi 0, A and B models, and the Raspberry Pi 2 and the Raspberry Pi 3 ones are pretty much the same. Again, we are not going into the depth and creating a 64-bit operating system. Rather, we are actually going for the default 32-bit one, which is supported by both Raspberry Pi 2 and a Raspberry Pi 3. So the first step would be to make the Raspberry Pi 3 def config, which sort of gives you a basic framework to get started. Now comes the fun part, is to make menu config, and this is the piece that would allow you to customize your sort of operating system at this point. So with the Raspberry Pi def config, you get a default configuration which will give you 94 megabytes big operating system, which is very basic, but it still can do a lot of stuff. But of course we need to customize it a bit more to include graphical user interface and all of that stuff. So first of all, we go into target options and we'll go through each of them and see what is there available already and what we have to change. In target option, we have to change pretty much nothing. It is preset at the correct settings because of the def config that we used. Again, into build options, this is sort of default and we leave it as is. And then into tool chains, here is what we will be changing our first couple of things. The one being change the C library to glibc, and of course the C++ support is already available. We don't need to change that, and everything else is also already available. In the build options, there is one thing that you might want to enable if you are going to make multiple builds and multiple clean builds, and that is to enable compiler cache, which would enable you to not necessary build each and every file and save you a lot of time. Next, into system configuration, here we do need to change a few things. So in the system host name, you can change it to whatever you like. I will keep it gtih OS, because that is what I'm calling this thing. And then again, this is the welcome banner just before the login menu, and again GTIH OS. So that's done. And init system, now a lot of people do like init system D, but from my experience it's not really working that well. I never get to the login prompt with system D enabled, so I will leave it at default busybox init system. Next we have the root password, and I do recommend entering that, and because it just makes it more secure. Make it anything simple that you like, so I'm just keeping it TOOR. So busybox shell, so the default shell that you would want could actually be anything else. You can keep it at busybox default, there is no issues, but you can also make it bash, which a lot of people like. So now as you can see, it's not available. We have to make it available if we want to run bash. Before we leave this area, time zones are essential to have automatic time updates, so we'll keep that as well. Exit and then into target packages. First of all, select show packages that are also provided by busybox. This would allow you to again set up bash as a default shell. So now when we go into default shell, we can select bash and exit out of here. In target packages again, let's go one by one on multiple packages. Audio and video applications, just enable also utils. This will probably give you audio. Then we have graphics, which is a pretty interesting part. A lot of things can be enabled and disabled. So first of all, let's look at our main GUI. Xorg, let's enable Xorg, but then also you want to enter further into that configuration, select servers and enable that as well. Make sure the settings are as you see on the screen. Then libraries, and pretty much everything is already enabled that needs to be. We don't need to enable anything here. Applications, we do need to enable a few things, including xinit, which would give us our start X option like we used to have at one point on the Raspbian OS. So we enable xinit. In drivers, enable xf86 video, FB turbo and FB dev, and input keyboard, input mouse. If you have touchpad, input synaptics, and that should be it. Pretty much everything else is not needed for a very basic setup. Fonts would be available automatically, protocols would also be available automatically, so would be utilities and other data, so we don't need to do much changes here. Now in terms of application, go ahead and enable some of the very basics one, including Xterm, which will give you a terminal emulator, PCman FM, which will give you a file manager that you can work, and OpenBox, which gives you a very basic window manager to make the whole GUI thing work. Also LeafPad, so you have a basic text editor as well. So as you can see, we are missing Midori, which is a browser. Now if you want this browser to work, you need to have libgtk3, which in turn requires OpenGL. Now we do have the option for Mesa 3D, so let's go ahead and enable that. In here you can see we have the Gallium VC4 driver or the VideoCore 4 driver, but for now I have done a lot of builds here and I couldn't find a way to make it work properly. All it did was give me a blank screen. So what we are going to do is enable both of the software renderers or SWRAST drivers, which would give us not a hardware accelerated OpenGL, but a software accelerated OpenGL nonetheless, which would again enable us to go ahead and enable libgtk3 for Midori. So to do that, exit this particular menu, go back to the previous one, select libraries, and here you can go into graphics and select libgtk3, should be right here, and then deselect VLAN and Broadway, we don't need that, only X11 GDK backend is enough. And then go back into graphics and libraries and select Midori as well, and you would see that it is now available. So with that, we have a very basic GUI setup. Next up, hardware handling. There's not much here, so let's leave that as is. Interpreter, language and scripting, I would recommend enabling Python and Python 3. And that's about it. Ruby if you want, and you also have the option for Node.js, Mono and whatever you want. So again, it is very customizable. Enable what you want and that would be in your operating system. Libraries, we can go ahead and into hardware handling, enable Broadcom 2835 and then wiring pi. That should in theory give you access to GPIO pins of the Raspberry Pi. So there is not really much that is required for a very basic system here. So let's move on to shell and utilities. Again, bash is already shown. Enable screen if you want some UART access, and if you want your Raspberry Pi to communicate you using a UART to TTL as an input. And then enable sudo time, and these are just the commands that are very frequently used, so enable these if not anything else. In system tools, enable htop, which does allow you to monitor your system health in terms of CPU usage and RAM usage and programs that are using CPU and RAM. Enable at least one text editor, go with Vim or Nano. I personally prefer Nano and many people do prefer Vim. So with that done, our very basic stuff is over and our system is almost set up. We do have to still get around the file system images that we will be using. Now here it is already set up for us at ext4, but since we have added a lot of other stuff, we need to increase the block size of our SD card. Now I am guessing around 1 GB will be more than enough, and let's go with that. So there are websites that would allow you to convert from gigabyte to block size. So 2097152 would be 820975152, and that should give you a 1 GB maximum block size for the root file system. Of course, that could be expanded later on once the operating system is booted up. Exiting that, we don't need to really change anything else, and this should give us our very basic system. We will be running on the kernel provided by the Raspberry Pi Foundation rather than the mainline kernel. Of course, mainline kernel is possible with U-boot support as well, so U-boot is also there. But I would actually just for the sake of keeping this video very simple, stick on the Raspberry Pi Foundation's kernel and no other bootloader, and the default bootloading provided by that kernel and other firmware utilities by the foundation. So this should get us our basic system set up. Now when we exit, before that, save it into the default.config file, okay, and exit, and then exit. From here you can actually type in the make command, but you have to make sure that you do not go ahead and type in the J option, which actually enables for multi-core rendering and multi-core processing and compilation on all the cores of your CPU. Instead, just use simply make command, because the multi-core processing stuff is handled internally by the Buildroot setup and by this make script. So if you actually provide it by default, it will actually spur out a lot of errors, and we don't need that to happen, because then it will be compiling at twice the amount of cores that you have, and that's never good. So simple enough, go ahead and press enter, and that should start the build. This would take a lot of time, depending upon your internet speed and the speed of your processor on your system. So of course it will go ahead and download a lot of these programs, a source code of these programs, which can be extremely big. So of course take care that you do have enough um, bandwidth on your network, and it doesn't cost you a lot, because it is going to download at least 10 gigabytes of data, and that's just from the top of my head and speaking from experience, and that should be around that. So I have already made several builds, so it may seem a bit faster considering I do only have a dual core hyper-threaded processor, but I think it should do good, and it will take a lot of time. So go ahead and get yourself some coffee, and we'll be back once it's done. Alright, so we are back and the build is complete. So let's go ahead and write it to our SD card, and since we have selected the Raspberry Pi def config, we now have a pre-built and ready to flash SD card image, rather than a rootfs partition image separately. So we have all the things that we require to boot from a Raspberry Pi already baked into that image. So first of all, insert the SD card into our card reader. I'm using a 16 gigabyte SD card, but anything can be used. Now there are already partitions on my SD card. The easiest way to deal with writing SD card on Ubuntu is to use disks. If you're not familiar with the command line DD tool, it's easier to actually use the disks software. It's big. It's included in the um, Ubuntu OS, and actually included in many other OS including Fedora. So this simply we can delete our old partitions, and then from here select to restore disk image, and from there go to Buildroot, output and images. Here you will have your SD card image. Select that and start restoring. It will ask for your password, give it what it wants. So once it's done, we'll go ahead, insert the SD card on our Raspberry Pi and turn it on.